tested on how different amounts of salinity in water affects the current flow of electricity. And this is basic water, just normal H2O molecules, and water does not conduct electricity well on its own. And that's because there's no ions in water to conduct electricity. So what I did what happens is you put a salt in. So as you can see, you put like just basic table salt, sodium chloride in, and it breaks up and ionizes in the water. And that allows the current flow of electricity. And this is another picture that you can just kind of see the ions within the water molecules. So what I did for my experiment, it's a fairly basic concept what I was measuring. So I think it'd be better if I explained how I did my experiment. Well, first I found my experiment, I thought it looked cool. And then I figured out how I could relate to material science. So I decided I would take a microwave transformer, which it's a step-up transformer and outputs about 2,000 volts of electricity at about between a quarter and a half amp. So it's really dangerous, and I didn't die, which is good. We just plug it into the wall and it outputs that. And you guys have probably seen the videos on Facebook and whatnot of this happening. But I hook it up to the board, I paint the water solution on, and I hook up each side, and I send the power through, and hopefully it burns the pattern. But basic water did nothing. There was no connection made between the sides of the wood. So that pretty much showed me that water is not a good conductor. And then I did 1 cup of water with 1 teaspoon, and it burnt a little pattern in on both of them. I did 2 tests for each. And and I really saw the difference with 2 teaspoons of baking soda with 1 cup of water. And it went all the way across on both of them. And then I did 3 teaspoons of baking soda with a cup of water. And this one burnt a different pattern. It was more spread out on both tests, but it didn't go as far as the 2 teaspoons. And I didn't actually bring those boards in the back if you guys want to see them, because it's cool. But no, I just wanted to see how this affected the salt content in water. Wanted to change the conductance, because I spend a lot of time in water. And if I'm out in a lake that's fresh water as opposed to the ocean and it gets struck by lightning, what are my chances? So it's kind of like something that I can relate to